Yeah.
All
So
right.
Sid will be presenting some slides. We're going to continue where we left off last time.
Yeah. All right. So thanks, Jeff. So last week we started out with looking at references of the between the various objects in this cozy ecosystem, and the original design was when you create a bucket, the user creates a bucket request, points it to a bucket class, and Cozy will use these two resources to create a bucket. And when requiring access to the same bucket, user will create a bucket access request, point it to a bucket access class, and Cozy will be able to use these two resources to grant access for this bucket for that user. Now, we had a design where if a bucket were to be shared between multiple, I'm hearing an echo. If you can mute yourself, that'll be good. So if a bucket were to be shared in this original design, we had this concept of having multiple bucket requests pointing to the same bucket. There were a few problems with this approach. The first one was we were dealing with many-to-one relationship, which is in order to be able to delete all the bucket requests when one of the bucket requests gets deleted, we'll have to create a many-to-one, a two-way mapping, which is complicated. Now, so in order, the second, actually there's another problem, which is the second one. The second one is portability. When the user creates a bucket request, if Cozy automatically creates a bucket corresponding to that request, there is a UUID for that bucket that's filled back into the bucket request field. Now, when you're trying to port this bucket request to the new system, the UUID will not be the same. So if we were to just use, actually, let me think about this. Actually, never mind. I don't think the portability is a straightforward issue as it is, but we'll get back to that. I want to discuss the approaches that we discussed, that we already talked about, and then we'll get into the inner details. Yeah, this is the same approach, but with multiple bucket access requests and multiple namespaces. Okay, this is the okay, this is the second approach, where in order to address portability issues, we thought that we could put the bucket name in the bucket access class. So as far as, and have only one bucket request for a bucket. So when a bucket gets created, there's a bucket request that, when a bucket request is created, corresponding bucket is created, and access to it is driven by the bucket access class or pointed to by the bucket access class. The issue we saw with this was as soon as a bucket is created, let's say user creates a bucket request to create a bucket, the user will not be able to access this bucket until the admin goes and creates a bucket access class for that bucket. The other issue is for every bucket, we'll need a bucket access class, and for every bucket and for every access pattern, we'll need a separate bucket access class. We mentioned that we'd be polluting the bucket access classes with a lot of entries. These were the issues discussed with this approach. The third approach, which we all more or less liked, was to deal with the multiple many-to-one mappings and actually to circumvent it. We said we can have one bucket request always point to just one bucket, so it's a one-to-one mapping. And if you want buckets to be shared between different namespaces, then you create a separate bucket object for that specific namespace and have the bucket request in that namespace point to that bucket. And to take care of deletion, if a bucket request that points to the bucket had the deletion policy of delete, we actually go ahead and delete the backend bucket, and all the other bucket requests which were utilizing this bucket will not be able to use it. So if the workload's using it in other namespaces, they might lose access to the bucket in the middle of its operations. So this is where we left off. So I want to today try and address all the different use cases that we have and check if these approaches, one of these approaches satisfies all of them. So with this approach, implementation becomes easier, and with the one that I'm showing right now, because of the one-to-one. And also we have the added benefit of the API review committee understanding this approach already. Now, the one question I have about this approach is portability. Now, I think Jeff or Rob, if you're on the call, you had a nice way of describing it. Do you want to take a stab at explaining this problem?
There's not a portability issue. The point, this is sort of Ben's, you're saying multiple BRs point and there's multiple Bs, and the bucket backends, the multiple B bucket instances in Kubernetes could all end up pointing to the same bucket in the backend store. And the issue isn't portability. The portability is solved because you have BARs referring to the BR, right? So you don't have a UUID name in any user defined spec.
Oh, right. Yeah.
It's called portability. What you have, what you're allowing though is, and you solve portability by making no user reference to a cluster-wide resource that has to have a unique name. So since there's no user reference to a cluster-wide resource, it's portable by definition.
Mm-hmm.
However, it means you can't delete use cases. You just yank the rug out from underneath apps. There's no mechanism to orchestrate deletes so that if a pod was running or a BR was still active, any of these BRs could delete. Now you could put annotations, or you could put ownership, or you could track who was the original one or something like that. Maybe
that's what the delete policy is for.
Right.
So
Could we say, right, to Ben's point, could we say that it's up to the admin to ensure that?
I wouldn't say there's no mechanism. I mean, the mechanism is you set the delete policy correctly, and if you set it incorrectly, you of course cause problems for yourself. But it's not that there's no solution; it's that we're punting the solution to the layer above us.
Right.
Well, what is I mean, we only have retain and delete. So
yes,
you have to set, the bucket class has to have retain if you're going to share. And if you don't have retain, if you have delete as your retention policy, then it's kind of the Wild West. You don't really know.
Well, right, but a good default would be for greenfield buckets to default to deletion policy of delete, and for brownfield buckets to default to retain, and you treat the sharing of a bucket into another namespace as a brownfield case, and then you stay out of jail as long as the guy who created it doesn't delete it while someone else is still using it. But then he's the guy who created it, so he's kind of.
There's also, I mean, I was getting some education from Xing on how PV sharing works in CSI. And it only works through static provisioning. And it requires manual PV creation by an admin explicitly putting in the volume portion, the IP path, whatever, of the volume, so that you can have multiple PVs reference the same back-end volume, but it's a manual task by the admin. and the PVC that's going to bind to that PV is pre-bound by a user. And that means that PVC knows the PV name, but the admin generated the name, so we're going to call that portable still. It wasn't a CSI generated PV name.
Right. So,
And
there's one thing I haven't heard outlined, which might fall into the portability concerns area, which is when you do want to import a brownfield bucket, we would, for snapshots and for PVs, currently you need an admin to help you do that. There's no way for user to just import a brownfield snapshot or PVC, but for object buckets, we would like that capability. So the question is there a way that we can structure the bucket request such that the user can supply the actual handle to the actual bucket in such a way that the provisioner will sort of import it instead of creating a new one?
Yeah, that's really going to be, that was going to be my next question.
Okay.
Yeah.
I think it's possible, but I haven't thought it through.
Right. In case of
I think in that case, we will violate portability again.
Yeah, because if you give the bucket name, for instance, we'll end up trying to, we'll end up tying the bucket request to a bucket name, and we lose portability. We probably can't use the bucket name itself for a brownfield request.
Why not the Kubernetes object bucket name?
Real bucket name, the backend object store bucket name.
So then, do we expect? So then, do we? Well, so it's a generated name here. The backend bucket name could be a generated name, right? So what happens then?
But it's a known name. I mean, it might be it might be a long name or have a lot of digits, but but if the user was accessing this bucket outside of Kubernetes, they need to know the name.
No, but say we're porting it to a new place where bucket by that name doesn't exist.
You mean they're changing the backend object store?
Yeah.
Yeah, and it's again like we can use the same application during deployment it goes through stages, right? Staging environment, production environment, testing environment.
Right.
And we will need to change the name every time, so it doesn't seem like that. That's why we probably will lose portability.
What if we did something like I don't know, just throwing it out there, label selector?
What is the concern?
The concern is portability.
Can't we randomly generate the Kubernetes bucket name and have the user just refer to the actual bucket name in the real world?
So the actual bucket name is also auto-generated.
Right, but it exists. It's a real thing that you can probably find out about.
Right. When you port it, the bucket request object will be pointing to a bucket name that might not exist for the current driver, for a new driver.
Okay, so there needs to be in order to if you know the actual bucket name on the back end, you can do an import. But the problem is that if you just create it through Kubernetes, you never find out what that is.
Yeah.
So you can't do it. So can we solve that problem so that when you create a bucket, part of its status information is its actual name, or is that a security problem?
I don't know if it's a security problem, but so let me rephrase your question. Are you asking if are you asking if we should consider a different approach for referring to the bucket name from the bucket request for brownfield buckets?
What I'm saying is, if you want users to be able to import them, they need into a place where they've never been before, like a whole other cluster, for example. Then the user needs to have a handle by which he can refer to it. And you would like to be able to get that handle for buckets that you've created yourself.
Right. Why obscure the bucket name, the true bucket name? Why not you pass that through all the way?
Well, I think there may be a security concern if you do that. So that's why I want to be careful about it. But it does seem like a good starting place to say, well,
What?
Just return it to the end user so he knows how to refer to it.
I don't know that there'd be a security concern with a bucket name.
Yeah.
It's a folder name, right? I mean, you only see it if you have permission for it anyway.
Yeah.
Right. Well, I guess what I'm thinking then is so I create a bucket on one Kubernetes cluster, and now I want to go use it on another Kubernetes cluster, and so I'm going to basically get the name from the first one and then do an import on the second one. How am I going to get access on the second one? Like, where's the power to sort of grant a new access token to that new cluster going to come from? Like,
So I'm talking
Would
about
that
a
be
different
manual?
case, Ben. So let's say I'm using MinIO, where you set up the object storage system within Kubernetes itself. Now, let's say I move my entire cluster from my on-prem to a different on-prem location. I set up a whole new MinIO cluster. Now, I won't be able to reuse the resources that I was using earlier because the generated bucket name in the first setup will not be the same as the generated bucket name in the second setup.
And
It's
it shouldn't.
Sorry?
And it shouldn't, because they're separate they're separate targets.
Right, but now I can't just redeploy all the resources I was using earlier.
No, they'd be net new, because it'd be a new cloud target, new set of buckets, new bucket access requests.
All you're bringing over are the user YAMLs, and the admin has to make sure the bucket access class and bucket classes match, and the namespaces match.
But they could be different bucket classes. I mean, you're talking about a different. You're going to a different platform. It'd be a net new target.
I'm saying names. If you're trying to, I guess I've defined portability as the user doesn't have to change their YAMLs.
Yeah.
They don't have to change names or anything. And if that's a reasonable definition of portability, then the admin has to make sure namespaces and bucket and class names and so forth are the same in cluster B as they were in cluster A.
Mm.
Class names don't have to be the same, right? Because we can still leverage default class names if we want to.
Well, fair enough.
Right?
Good point. Yes, if you're using a default class name, then that point goes away.
If part of your workflow is to like create brand new buckets, then as far as I'm concerned, like portability implies that you're okay with creating brand new buckets after you move to the new cluster, because that's what would happen with PVCs, right? PVC data doesn't magically move around. If you request new PVCs, you're going to get empty ones.
Yeah.
So if you want to bring your data over to another place, like it's not just copying your YAML. It's actually saying, okay, I need to actually import the data that existed in this other place onto the new cluster and then refer to it with my app, and the rest of it should be portable, but data doesn't just magically move around. You have to import it.
Yeah, there's no portability from backend target to backend target.
Exactly. I'm not thinking about moving data at all, Ben. I'm thinking only about moving of Kubernetes resources.
Okay, but the whole brownfield bucket case is like referring to data that someone else created, right?
Guys, could you remind me, we used, like in the very beginning of this like CAP, we used to have different bucket class format for brown and green field. Whereas for brown field, bucket class will explicitly say to which bucket this bucket class belongs. Is it the case right now, or we kind of moved away from that?
We didn't have that at the beginning. Andrew proposed it the last meeting a week ago, as a way of dealing with portability, that the bucket access request would not name the bucket instance, but the bucket access class would name the bucket instance, and that's an admin responsibility. So that portability problem is removed from the user space.
Right. I remember this specific idea was actually, it wasn't even Andrew's. It was before I think maybe even before this CAP, and Andrew maybe even knew about this problem. I think it came from somewhere else. But I thought we followed it, but we don't follow it. Okay.
We used a storage class for the bucket library that's a couple years old now.
Yep.
And in the storage class parameters field, we had a bucket name key. And so you would put the real physical bucket name in there in the storage class, and that's how brownfield worked.
Yeah, I think.
Okay.
Yeah.
Thank you.
Yeah, I think that's a good question, actually. So I want to actually get back into this portability thing. So how do we define portability here? Should the
Well,
user... Yeah, go ahead.
yeah, I think that's really important. Is
Yeah.
there's a difference between portability in terms of I can take an app that ran in one cluster and run it in another cluster where they, I'm okay with starting over from nothing. And then there's I want to migrate. I want to actually share data across multiple clusters, and that's not what I think we typically call portability. That's
Right.
actual data sharing.
So in the option one that you mentioned, when you say you want to be able to take the YAML that you use in cluster one and be able to use that in cluster two, should the user be expected to update whatever reference they have to a bucket depending on where they are, or should it just work no matter what?
If your application expects data to pre-exist, then there's got to be a step to sort of import pre-existing data before you set up your app.
You're adding data migration into your definition, and it
but brownfield implies like I want to be able to refer to pre-existing data.
Yeah.
Yes, pre-existing, but the data doesn't ever have to move. If I have
no, yeah, I'm sorry, I never meant to imply the data moving. I'm saying just two clusters may be referring to the same object store.
Yes.
So I'm moving my application, and I want the data to sort of already be there when I get to the other side.
Right. Well, okay, but and the data's endpoint that is the same.
Correct. So portability should be between namespaces and Kubernetes clusters, not object stores.
Right. And so if the bucket pre-existed both clusters, then both of them would just basically import the same bucket and start using it. But if one of the clusters created a bucket, and now the other cluster, and then you want to move your application over to another cluster, like it would be reasonable to assume it would also create a bucket that's initially empty. And the whole problem is, what if what you wanted was to create an empty bucket the first time and then reuse the bucket the second time? Now you have to do something special. Like there is no magic anywhere in Kubernetes that will solve that problem for you. You have to do something.
You'd have to be able to import all of this that we're talking about, the bucket requests, the buckets, bucket access requests to the new cluster.
Well, you should be able to reuse the bucket access request, but the bucket request in particular should say, I don't want an empty bucket. I want this other bucket that I already made on this other cluster.
I think portability, we can, again, like I'm not sure about definition itself, but like I store my YAML files like as a user in GitHub, and I want this YAML files be like a source of truth for my application, and I want to reuse them everywhere, like no matter environment.
But so if you want that, then you can never use the cozy provisioning method of creating a bucket.
Well, basically I can, if bucket class itself will have some information, for example, distinguish between green and brown field. So in one case, for new bucket, I will use bucket class, which will say, okay, if it's a green field, you create a new bucket. And for brown field case, in a new cluster, bucket class will say, okay, I want to reuse this specific bucket. And my application YAML will be absolutely the same. It will just pick up a new bucket class, which will instruct provisioner to reuse existing bucket instead of creating a new one.
So,
this problem exists with PVPVC as well, if we look at it that way.
This is a good example of a way that you could work around it, but the problem is that a storage class could only ever refer to one bucket. Right? I don't see how you could make a storage class that says this is the brownfield storage class and it can deal with multiple buckets somehow. So you don't want to end up in a situation where you need a brownfield storage class for every bucket.
But that's
like, I get that if you only had one, that would be a very elegant solution, but no one ever just has one.
And also with PVPVCs, you can match. You can do a matching based on access modes. I don't think we can deal with that undeterministic matching in case of buckets. So in PVPVC, you can say, I want a volume that has these access modes. The storage.
Well, yeah, it's a good point. Even in PVPVC, you have you can have predefined matching.
Yeah.
If PV refers by name to PVC, it
Yeah.
will always match.
Yeah, but
Yeah.
then if it's provisioned and you take the you've set the PV name to say some PVC-UUID, which is how it looks if it's provisioned, and then you just take the same PVC definition to another cluster, it won't work for you, because here when you provision it, the UUID will be different.
When we look at portability and the idea of brownfield or sharing, CSI is not portable. If I have to do static provisioning, if we do green CSI, and now I have a PV pointing to an NFS, NFS system, right? The NFS volume. Okay, and now I want to share that. I have another PV that has to get manually generated to refer to the same NFS volume, okay? And then I have to bind a new PVC to that manually generated PV. And well, I guess the name was admin created.
Mhm.
So I think that means it doesn't have a UID in it, so it would be portable.
The brownfield case. So I think what we're trying to say is the portability guarantees that this method provides, that this approach provides, is no worse than what, or no better or no worse than what PVC has. And I think that's okay.
I think the
I'm-
definition
I'm-
of portability of the GitHub Git
you have-
repo that has all your user YAMLs working on cluster B is reasonable. That's what we're trying to achieve also.
Ben, were you saying something?
No, so I'm sorry.
Sorry?
I'm
Can
trying
I
to.
just add this PVC, PV? Maybe we have some misunderstanding how mapping works. You can create PV, manually PV, and just provide a PVC name and namespace. You
Okay.
don't need to provide UUID, right?
No, I understand. If it's dynamically generated,
I think that the problem is the dynamic generation of the bucket is where we're struggling, right? And making it portable.
yeah.
I'm still don't quite understand why
Yeah.
that is a problem.
So if you dynamically generate it, and the PVC name, if you have a PVC that dynamically generates the PV, and then you try to just take that PVC object and then try to put it in a different, I guess
Cluster.
if we put it in a different cluster, I think it will still work in that case because it's generating it dynamically again.
But what you'll get is you'll get a new empty volume. Like if what you wanted was to start your application on one cluster and have it write some data, and then kill that cluster and take the same YAML and shove it into a new cluster and have it continue with the old data, it's not going to work because
Correct.
it was
But
generating volume.
in my GitHub, I have PVC, which doesn't refer to any PV, right? So it doesn't have any PV reference. It's kind of
so it's
clean.
more, that's because
so when I want to port, I pre-create PV with the name of my future to be PVC, just name, no UUID.
right.
And then I deploy my application with well-known PVC name.
Well,
And
actually,
that
you
will,
don't give the name. So you don't even give the name. Generally, it's just access mode matching. You say, I want something that has these access modes. That's it. And
it's one of the possibilities. It's absolutely one of the possibilities. But another possibility, and which I think even precludes what you proposed, is that if there is any PV with the name which refers to my PVC, new PVC, that will match automatically, even without any further kind of checking. Or maybe there will be checking, and if it doesn't match, maybe there will be an error in that case. But basically, they try to map by if PV
name
refers to PVC name namespace. Yeah, so it checks the namespace.
Let me ask you this. So if I have a PVC that's referring to a PV, okay. So it got matched somehow, and then it's referring at this point after matching to a particular PV. I can't take that PVC spec as it is and then use it in a different cluster.
Sure, absolutely. Yeah, I think once PV starts referring to specific, PVC starts referring specific PV by name namespace, I think it stops being portable.
That's
because
exactly
PV information is not portable.
That's exactly what's happening here. So instead of the matching doing the referring, the user is expected to do the referring. That's the one difference. And in this case, exactly like that. If it already starts referring, then it's not portable. And I think that's okay. It's no.
That's right. Yes. Yes, I think I agree with you. Yes, it's okay. If bucket request starts pointing to a bucket, then this bucket request configuration is not portable anymore.
Right.
I think I agree with that.
Right.
But if a bucket request, a brownfield bucket request, points to a backend bucket, qualified backend bucket name, it's portable because the bucket name, the backend bucket is still the same, no matter what Kubernetes cluster I'm in.
Huh? No, I think Jeff, are you talking about the brownfield case?
Yeah.
Yes, the case Ben is referring to, Greenfield's no issue. The case that is more interesting is the brownfield.
I have a question here actually. So how do we, let's say I create a bucket request in one namespace, it ends up creating a bucket. Now, how do I use that bucket from a different namespace? How would that cloning or whatever we want to call it, how do we import that bucket to a different namespace? Let's use the word import. It seems more intuitive, at least to me.
So you'd have to have a way to kind of export it initially and get the relevant details from the original bucket object or bucket request object that would point to the actual bucket that needs to get imported.
Let's see.
Yeah.
So
if just a wild idea how it may work. You just copy the source bucket as is mostly, but in bucket request reference in the bucket, you change it to a bucket request, like to be bucket request, a new namespace, a new name of the bucket request. So and then you go ahead and create bucket request there. And again, like as PVC, it will automatically just bind.
Okay. Again. Oh, I see. Yeah. I see. That makes sense, actually. We could do that.
Wait, so what do you put in the new bucket request, in the new namespace?
I may put there a reference. It's going to be just like bucket reference will be blank there.
But then you'll get an empty bucket.
No, not necessarily, because there must be a matching mechanism anyways. Like well, not anyways, but we can have a matching mechanism, and it'll see all the buckets.
Bucket name. Backend bucket.
It will have all the buckets. This matching mechanism will just go through all the buckets which are not bind yet and see if that bucket is referencing this new bucket request. And if there is any bucket that reference us, it will just automatically bind to existing bucket.
Get created again, because you'll need a second bucket object that points to the, like, who will create that?
Admin will. Nobody else can, right? Because it's not namespace.
So my hope had been to provide a mechanism to allow people to do this without an admin's intervention. Like maybe that's not possible, and maybe that's where the security comes from, is because the admin has to do the step for you.
Right.
Well, the name of the backend bucket, you mean?
Well, it's not just that; it's the credentials for the backend object store, right?
So in the current model, the credentials for the backend object store is given to Cozy. The system has the credentials. Now, the question is, if a new namespace requests a bucket that already exists, how does the new namespace refer to it? Like
when you say the bucket that already exists, you mean an actual bucket that exists, or the Kubernetes object?
Kubernetes object exists in a different namespace, let's say. Well, Kubernetes object,
the bucket is not namespace. You just have a second copy of it with a different name.
Right.
That refers to the same actual bucket. And then, but if the admin creates that, sure, you could sort of create a pre-bound bucket request that refers to it, and then the provisioner will say, oh, it's a half bound. I'm going to complete the bind, and then it'll be done. But that requires the admin to have basically cloned the bucket object at the cluster scope.
Well, what if that?
What can be alternative here? Like if we want to create a new bucket, so we want to avoid one-to-many relationship, right? So we need to create this new bucket. So I'm trying to understand what's the alternative here. Only admin can create non-namespace.
The alternative, right? In my imagination, was you have a special field on your bucket request spec, which is optional, that says, this is a brown field, I want to import it. And then when the provisioner sees that, it says, oh, I should not fulfill this request by creating a new bucket. I should fulfill this request by cloning an existing object and then binding to that.
Instead of
the controller could do this for you if we wanted it to, but I worry about the security implications. So I haven't, like I said, I haven't thought that through.
Oh, so actually, so it's not. So we have the concept of allowed namespaces in a bucket. So if the bucket request comes from one of the allowed namespaces, we allow it. Otherwise, we don't.
But this assumes you are sharing the bucket. Otherwise,
Well, and it assumes that the namespace exists when the bucket's created.
Well, if not,
no,
it's
just
okay.
referenced by name. It's
Yeah.
just
No.
set of names.
The bucket isn't namespace. The bucket request will be, and the controller has to decide whether to allow it to bind or not.
Yeah.
If it's not in an allowed namespace, it would just refuse to complete the bind.
Right.
And you'd have a dangling bucket request that would never bind.
Right. It'll have an error field set that, brown field bucket cannot be found or something.
But then why do we need two objects to represent?
Because you
why
do.
do we need also bucket access? No. Why do we need bucket access? I mean, for PVCs, you don't PVC and a PVC access, right? You don't have
we
a PV
need
access.
Andrew Large to answer that question because he's very good at explaining about credential minting
No,
and
so
all the
the reason for bucket access is, we can have different types of credentials for the same bucket.
Right.
I don't think that was the.
I'm kind of presuming that if you import a bucket to another namespace and you also create a bucket access request in that namespace, you'll get a second credential for the new namespace to access the old bucket.
Yeah.
Which is what you would want, I would think.
Yeah. No, this is what you want. That's the common access pattern.
It's a request for access, right? It's only something logical in the sense that you request somebody to either provide you with existing credentials or new credentials, but it's the reason for it was
there is no request for existing credentials. The two kinds of access you give me credentials of
the driver can do that. I mean, you're saying no, but I mean the driver can decide.
Fair point. Yeah.
Can decide to have like a single credential per namespace or a single credential per cluster, whatever. Right? That's
you're right. Yeah. So but we leave that up to the driver. But generally a bucket access, it really represents one type of access and a separate service account, where not the Kubernetes service account, separate say cloud service account that's actually accessing the bucket, and each one wants to access it in its own way. Some might just want to write, some might want to read and write, and whatever.
For PVCs, you don't feel like there is another object in the way, right? You need another object.
PVCs, you just mount the block device or the file system, and then
but you might want read only. You might want some policy applied. You might want a lot of things from file systems
done on
and objects.
The PV itself. It's not done per user.
What do you mean per user? Yeah.
So if I have in this case the credential is given per user, that is the access pattern is independent of the bucket's access mode. So in PV and PVC, if you create a read-only volume, nobody can write from it, right into it. In a bucket's case, a bucket is just a bucket, and each user gets a completely different type of access. The access is not on the volume itself. The access is on the user. Like it's driven per user, or it's given per user.
I don't think these are very different entities with, I mean, I think eventually these are, there's policies applied to the bucket versus policies applied to the mount point or the pod that gets access to that. And I think for PVCs, it's probably in the mount somewhere where you have options to set.
I think you're right. Yeah, right. I think for PVC case, it's basically very similar.
And my only question is this: if we are using bucket request to represent even, referring to an existing bucket, referral to existing bucket, just my question is, what is the difference between these two objects? Are they saying anything new from the application side about, because it seems like we are asking for access to bucket and an optional creation. We're saying something like that.
I see where you're coming from. You're saying the bucket access request is not needed. That one object is not needed.
Or the other one.
I think I think it is. I mean, I think Andrew does a good job of explaining why it's needed. I'm not good at channeling him. I will say the difference with PVCs is that with PVCs, the hypervisor, the node has the ability to like remount a volume read only. So if it mounts, if the volume is exported to the node writable, the volume, you can make it read only for just one pod by remounting it read only before handing that mount off to the pod, and you can sort of enforce it that way. With objects, there's nothing standing between the pod and the object store, and so if you want to give one pod read only access and another pod write access, you have to hand them two different credentials.
Yeah.
And my understanding was that the bucket access request corresponded to the credentials.
Yeah.
And you're right, you can play games where two different bucket requests might actually refer to the same underlying credential, but that's an implementation decision. At the Kubernetes layer, every bucket access request is a separate credential, potentially.
Yeah, this is what I was go on.
I didn't perceive it this way. I mean, I just perceived it as a request for credentials, and not you know, it wasn't defining.
It ends up corresponding to actual credentials.
It refers to credentials. The question is if it is referring to credentials, saying these are my, I'm a unique credential. You know, it's basically the same case about buckets, right? Are we representing a case where we are?
Yeah, we call it minting so that we create them. Yes.
Well, I think this is, you know, it's just a restricting way of defining the API. But, you know, if you really feel like there is a good reason for restricting how the driver returns credentials, yeah.
But we're not restricting still. So what we're saying is, if the driver wants to return existing credentials, that's up to the driver. But and if I mean,
I think maybe the other half of it is, there's a life cycle. So if you create a pod and you attach it to a bucket, it's going to need a credential. Something has to create that credential. You could try to do it just in time, maybe, but then the question is, when is it safe to delete it? I think having the bucket access request be a formal object that gets deleted at some point means you know when it's safe to delete that credential.
Only for that pod. So other pods still get to access the bucket.
No, not if they're using that bucket access request.
Right, not if they're using the same bucket access request, right.
So that's the whole point, is the bucket access request's life cycle tells you what the life cycle of the corresponding credential must be.
Mm-hmm.
So let me ask you this. What is the relationship between pods and then bucket access request? Is it a many-to-one?
No, it's one-to-one. It's just we can have multiple pods mapping to the same bucket in a particular namespace and having different access patterns. So I can have
PVCs, for example, it is many-to-one, right? You can mount multiple PVCs, which are rely shared from pods, right, all over.
So I think it's many-to-one too here, right? One pod can have access to multiple buckets, right? So it means
no, the other way around.
Well, I think it's many-to-many, right?
Many-to-many, right? That's sure.
Maybe even many-to-many, right? But at least many-to-one, where one pod can have multiple its own bucket access requests.
Yeah,
that's for sure.
And within the same namespace,
I meant the other way around.
Within the same namespace, multiple pods could refer to the same bucket access request.
So Guy, I'm trying to understand what you're saying. How is it restrictive? How is it restrictive to give the driver the ability to decide if he wants to give existing or new?
It is not. If that's what we're saying, it's of course not. The question was, when you are referring to this as, if you define API as mint credentials, for example, it is something.
I see.
From the driver, I mean.
Right. So you're saying,
if you define the API, I'm requesting, this is the request, please fulfill it, provide credentials, and the API, the driver can provide credentials, but defined by the bucket access class or whatever. Like, I have configurations for that, right? So
sure.
I can decide.
Sure. Yeah, it can be an existing or a new one. Yeah, that's how we've been designing it so far. That's why I guess I was trying to clarify your question. So, do you still see not see the need for the BAR? Is that still, is that...
I just think that the thing, I don't have a good gene yet. I have to say, first of all, but the problem that I see is whenever we are referring directly between a bucket access request to the bucket, which is what we suggested originally, right? On that, then the bucket request becomes just a creation facility,
Right.
And when we move that back to be the bucket request is just an import facility, right? Then when that is the case, I'm just questioning why are we using two objects in order to import a bucket?
It's not just
But
import,
why do we
it's
need
also
two?
creation, right? If I want to ask for a brand new bucket to be created, that's what the bucket request is for as well.
Right. So you're saying that the bucket, the cluster scoped bucket is getting created, but I'm talking about provisioning a bucket like the external entity.
Right. If you create a bucket request that doesn't refer to any existing bucket, the expectation is you get a new one.
No, I think he's asking, in case of a brownfield, instead of a bucket request pointing to a bucket, why not just have the bucket access request do the cloning or the import?
Because then you end up with all the weird relationships between the Kubernetes objects, and you can't keep track of it, right?
Implementation is complex.
In this case, I'm basically asking, why do we even need two objects? Why aren't we enough with just bucket request and mounting and asking for referring from pods to bucket requests? Why? What makes it?
No, we're separating access and creation. Provisioning and access are two different concerns. That's the line.
Bucket request is not creation anymore. I mean, it's not.
It's still
some field inside the bucket request that.
It's still creation of the bucket object. So I see where you're coming from. Actually, I know what you mean. It is right now a bucket request for brownfield is really not doing anything other than doing some internal Kubernetes management. As far as the user is concerned, why should they do a bucket request for a bucket that already exists? That's a fair question. But given all the constraints we're dealing with, this is the model we're going with. And I think, going forward, if we find a better model, we should definitely go for it. But as it is right now, I think it works, and it's really not too bad for the user. It's something we can easily document and explain. I mean, there are some things that are way more complex in Kubernetes compared to this.
Yeah, but as I mentioned before, like user may not even know ahead of time if they want a new bucket or they want an existing one. Mm-hmm. Their application should be portable in the sense. Maybe I'm making this up, but it's just something that comes to me. When I have my application, I really need just storage to talk to in some cases, right? I don't care if it's a new one or it's an existing one. Mm-hmm. And I want to use the same YAML kind of for my application. I don't want to worry about new or old bucket.
But who do you expect to fill in the gaps? Who is the
point about
the admin?
Yeah.
That statement about an application not caring about whether it's a new or existing bucket, is that, I mean, what is your collective wisdom on that use case? Is that actually common or important?
Well, I just imagine, for example, again, like if we're talking about application which goes through stages. In testing environment, it's okay to create a new bucket and test against new bucket every time, right? But in my product environment, I can probably there is an assumption that there is already some existing bucket left, which I should reuse.
Yeah. So in that case, we're saying the bucket request, like Ben was saying, there's a switch, there's a field like a brown field or green field, or we could, rather than putting it that way, let's have a bucket name field. If it's filled in, it's brown field. If it's not, it's green field. And in say test and staging, it's not filled in. And production, we fill it into exactly what we want.
Yeah, but Sid,
right, but it involves mocking, like updating my application, and anything can happen when I update application, right? So it's like it's just becomes.
I mean, regardless from going from staging to production, there is manual steps involved.
Well, not necessarily, right? It's like ideally there shouldn't be any, like if we are talking about ideal situation, sure, there might be.
I mean, so how would you, like, let's talk about the behavior in production. So behavior of this application, So are you saying that the user will not even care if it's greenfield or brownfield, and just like that, somehow the right bucket is provisioned?
Ideally, yes. On the other hand, a user, okay, even if it's a brownfield, sometimes the just names should be different for bucket names for different environments, right? So I don't want to hard code like any name in my YAML. I want to use the same one for all the stages.
So generally what people do is, like in the pod spec, they'll have different service account, different config maps pointing to, say, environment variables. All that is changed between prod and staging. That's how, if you see customize or if you see Helm, in both cases, in terms of environments, the data in the YAML changes.
Well,
that's
not in the YAML, right? I think it's, well.
It does. So,
what I hear is that you want to be able to write an application such that whether it's a greenfield or a brownfield deployment becomes a deployment time decision, and you don't have to change your YAML to achieve that.
Right.
That's correct. Yes.
And that does make sense to me. And so I think we should make sure that like the bucket request can be written in such a way that that it can be a deployment time decision. Like I think we don't currently achieve that with CSI snapshots. I think with CSI snapshots, it always you can't request an empty snapshot. A snapshot always says.
Oh yeah, I think snapshot is not portable. I think snapshot is it's a beast which is not really portable. I agree with you totally. But for example, PVC, right? I have the same PVC definition. I don't care what's the underlying storage, right? It might be in Google Cloud, it might be PD, and Amazon, it will be some EBS, right, or whatever. And so you don't care. You have one PVC definition, and it's portable through cloud providers or even on-prem.
So question is, so we have only 5 minutes, so I want to stop right there. So question is, how important is this for MVP?
I think we need to have a way to do it. I think if we get it wrong, it's alpha and you can fix it, but we shouldn't just punt and have no solution. We need some kind of some way to do it, and then hopefully it's the right way.
When you say a way to do it,
the PVC model.
When you said a way to do it, do you mean importing, or do you mean green
deployment time decision
in a BR?
We need to define like a workable brownfield mechanic where you can create a bucket and have Kubernetes create that and then reuse it somewhere else by importing it, and have a credible story for how that would work.
Yeah, so PVC does it through matching. We can do something similar, either by some parameter in the bucket or labels in the bucket and select those labels. So the BR would just select the labels that it wants. And one of the buckets that satisfies that label selector would be given to the BR.
Yeah, I think it should be only one, right? We are probably talking about deterministic.
Yeah. So yeah. So some of the parameter, like in case of PVC, it's the access mode. So some set of parameters.
The classic PVC binding wasn't deterministic either. It was a best match. There could be multiple PVs that fit the definition of best match. And so you couldn't tell which PV your PVC would bind to, not necessarily.
That's right.
Right.
But nowadays it is possible.
I don't know how often that's done, Xing, or you guys that are using PVCs more with CSI. It doesn't seem like we're doing that access mode best match very often anymore.
A lot depends on the storage class. If the storage class points to a CSI driver, then the external provisioner sidecar gets to do whatever it wants.
Right. Right.
And so I don't think with CSI in particular, it's possible to do the kinds of things you're talking about with matching. But we should we should find out what the closest analog in the PVC PV world is and try to model it after that, because that seems like a reasonable thing to copy.
So the question is, we were saying this earlier, in the PVC PV world, if the PVC contains a PV name that's already built in, then that PVC is no longer, I mean, written in, plugged in. The PVC is no longer portable.
That's only if it includes a generated name. It could be a statically created.
That same thing applies here too. If it's
Yeah, if you put any name at all in your PVC, then the provisioner will not provision a volume for you. So
Right.
if what you wanted was an empty volume, you cannot put a name there.
Yeah. So here too, the same thing, right? Like if you put a name there, we're saying it's an existing bucket, and it's not portable if you put a name there. But if you don't put a name there, it's always a new one, and that is portable, exactly like PVC PV.
Except that we're trying to solve an extra use case. We're trying to solve this green to brown sharing across namespaces, and that isn't done automatically.
No, that's the same thing, right? Like in that case, you're putting a name in the bucket request.
No, but listen, I said it was created, but the bucket, which is the PV analog, is created by Cozy, so it has a UID in its name. That's the difference.
So when you have a read-write many volume, does it mean we have multiple PVCs binding to the same PV?
No.
No, we don't.
I don't think
you have multiple pods binding to the same PVC.
Got it. Okay.
Yes. It's always, there's always a one-to-one mapping between PV and PVC. I'm not saying that.
Yeah, fair point. Yeah. So in this case, we're generating it, and in case of bucket request, we're actually plugging it in. There's a difference.
But if you're doing green to brown, you have to create a second bucket, and you can, when you create that bucket, you can decide to give it a friendly name or a randomly generated name, or you can name it how you want. When you create the second one, the system will make the first one random.
I mean, right? Yes, the first one random. The second one, it still has to be unique. So
right, but the admin, it's up to the admin to do what he wants there.
Well, so yeah, if the admin is but part of this discussion has been Cozy is doing the clone, but now you're saying the admin is.
Well, so I had been hopeful that we could automate that part of the process, but no one else seems to support that idea. Everyone seems to think the admin has to get involved with the importation of a bucket into a new namespace or a new cluster, or.
Right, because that's the.
I don't think that's a good idea. Actually, I think it will. I mean, it's not usable in this sense, right?
It's
certainly less useful.
No. I mean,
I think
it's not dramatic. It's not dramatic.
Yeah, I think I agree with. If we can automate that, it would be even better. Any great solution for automation, I think, will be better than this.
I think brownfield becomes, something very, very limited in that sense.
No, brownfield across namespaces becomes limited. Across namespace, in the same namespace, we're good.
It's not really brownfield. It's the same namespace. It's what is
in the same namespace?
Just,
yeah, it's like
it's just reconnecting.
Right. Okay. Fair.
Reinstall or something.
So across namespaces, admin has to get involved is actually a difficult user experience. That's what we're saying, right?
Yeah, so I think we have to come up with some answer here, and it doesn't have to be the best answer, but we're out of time, so we got to.
We have an answer. The admin has to do it. It's just we don't have an answer for automation, and I'm not sure. It could be enough for MVP, but I think everyone has to agree on that.
Yeah, the other question would be what is this use case for actually create bucket in one namespace and then reuse the same bucket in the other namespace? What kind of
I mean, yeah, that is kind of odd to me also. So I can give some info about how MinIO is used in VMware. A team gets its namespace, which has its own MinIO tenant, and everything is constrained within the namespace. And if someone outside wants to access it, they create an external service from the other namespace pointing to this one. So
I see it in manufacturing.
Mhm.
You'd have different namespaces, different clusters, and have to work with the same data sets or do the next steps with the same data set, right?
Yeah.
IoT would be another big one where it'd be important. And again,
Yeah.
those.
Yeah, well, the question would be like, do we need to automate then that in that case, or it's just it doesn't have
Guys,
to be
I have to
like.
drop off to go to another meeting.
Yeah. Okay. So yeah, I think the open question is: do we automate or do we leave it as it is? I think one way to discover it is to actually put it out there and see how if people are screwing this up a lot, or it works fine, or is there questions rarely coming up about this? That way, we'll actually be able to find out if we need automation there or not. Any questions? I think we should end at this point. Any questions?
I have a question, but I think I'll follow up on Slack because I think it's not enough time. So.
Okay. All right. Thank you, everyone. We'll meet on Monday again, and we'll try to make a decision on Monday about how to take care of this. I'll see you on all then. Monday at 11 PST.
Should we try to get Andrew there for this one? Seems like we need to get some feedback from him, right?
Yeah. Well, I think the question is pretty simple. I don't know in what particular way we need Andrew, but he's been a very important part of this community. So he should, like in that sense, before we make a decision about the KEP itself, he should be present.
Okay, thank you. All right.
Thank you, everyone.
Bye.
I will ask him to join.
Sorry.